All right. So for example, number one, we have a times x minus 2 minus b times x minus 4. By the way, this three-line equal sign here is read as similar to. Okay. For some books, they use equivalent to. Okay. Okay, they're just the same thing. All right. So, but for me, I'll just use similar to. So this side is similar to x plus 2. So basically, class, for this question here, we need to expand and simplify this side. Okay. And this is where we compare our answer here once we have simplified this. Okay, so this is how it works. Okay, so I'm going to evaluate the left-hand side. So LHS means left-hand side. It's the left side of the, let's say, the equal sign. Okay, and then what's next? So write this again. Okay, and then how do you remove the brackets? So basically, you distribute them to this terms inside the brackets, and then you'll get ax minus 2a, and then doing so here, you'll get minus bxn plus 4b. Okay, are you guys following? Okay, so we are simplifying this. So once we're here, what is the next thing that we need to do? Okay, we should combine all the similar terms together. What do I mean by that? Combine all the x squareds, the x's, and then all the constants. Now, if you look closely on this one, you only have a pair of x, right? So we have x here and then x here. Okay, so what I did here is group them together like this. So I have ax minus bx. So you put them side by side like this. Okay, and then what happens with this? Minus 2a and 4b. So you also put them at the last part of the expression. Why is that so? Do they have x or even x squareds? No, right? They don't have x or x squareds. Now, if that's the case, that means that this 2 here is your constant. Okay, that is equal to your constant. Again, if they don't have any x squared, x, or any variable terms, that's what you call, or that is your constant. Okay, basically they're equal to this because this is your constant, right? This is also your constant. Okay, so now after we have rearranged them like this, what do you need to do next is just to factorize this. Okay, so when I factorize this, so basically you factorize a minus b, right? And then you have x outside the brackets. Okay, so do you have any question, class, on this one? Okay, so how did I get from, to here, from here? Do you have any question? Hmm? I just factorize a minus b. And then, of course, the common factor is x. All right, so maybe let me just explain this more. This one. So look at this. So ax minus bx. What is common? Common is x, right? And then if you divide each term by x, what will you get? You get a minus b, right? So it's the same thing as this. But instead of putting it in front, I put the x behind the a minus b. Because that's how we write coefficients, right? We write the coefficient in front of the variable. We write it as, let's say, 3x squared, right? We don't write this as x squared and then 3, right? So same concept here, class. So I put the a minus b in front of the variable, okay? All right, so it can be here, but just to be uniform, just put the common factor here. Okay, so that means, class, that a minus b is your coefficient for x. Okay, this is equal to the coefficient of x. So what do I mean by that? Now, let's compare. Now, we have simplified and factorized this. So let's compare it with this. Okay. Um, so this is compared with this? What is, okay, or how can I compare that? Because both of them has x, right? Right? And then how can I compare this and 2? Because this expression here, class, is your constant. Basically, in simpler terms, they don't have x or x squared. That's why this 2 here became equal to your constant. Okay? So again, we compare the coefficients of x, and then this is your constant. Okay, so let's compare them now. So we have a minus b equals to 1. Where did it come from? So a minus b is the coefficient of this. Okay, coefficient. All right. And then where did I get equals to 1? The 1 came from here. Right? The coefficient of x here is 1. All right. So that's how I got a minus b equals to 1. And then since I don't have any value yet for a and b, I'll just keep it as this one. Okay, a minus b equals to 1. Okay, so this is your first, first, let's say, expression or equation. Okay, how about for the constant? Okay, so this is our constant, right? So this is equal to number 2. And that's how I got this one. Okay, so by comparison of the constant term, so this one is this, and then this one here came from there. So I'm just comparing the constant terms here. Okay, and then simply on this one, you need to perform simultaneous equations. Okay, what I did here is just to perform some substitution method, right? So what I did on the first equation is I made the subject a, so it becomes a is equal to 1 plus b, and then I substituted this in here. Okay, so yeah, so that's why it became negative 2 times 1 plus b plus 4b equals 2. Okay, and then so basically, class, you need to solve for b. So what else one? Distribute this one, so you'll get negative 2 minus 2b plus 4b equals 2, and then so on and so forth. B is equal to 2. Okay, so b is equal to 2, and that's correct. And then how do we solve for a? A is equal to what? Equal to 3, right? So from here, since we know what b is, so b is 2, right? So it became 1 plus 2, and then that is equal to 3. Now, question, is it always simultaneous equations? Do we need to use always simultaneous equations when solving for a and b? No, it doesn't. Okay, that's why I have 3 examples for this one. I have 3 different examples on this one. For number 1, it so happened that we need to use simultaneous equations in order for us to solve a and b. But for the next 2 examples, you don't have to use simultaneous equations. It's much easier to solve the next example. Okay, so that's how you solve polynomial identities. So this is by merely comparing the coefficients of the left-hand side and the right-hand side. So class, this is like your guide. This is where you compare the coefficients on the other side. All right, maybe let's have another example. Let's have example number 3. Okay, now this one, you're given 2x cubed minus 6x plus 5, right? And then is similar to x minus 2 times 2x squared plus ax plus 2, and then plus b. So again, class, we need to solve for a and b. Okay, a and b. Again, this is similar to this one. That's why we can solve this by comparison because of this sign. It's similar to each other. So what I'll do here is I will evaluate and simplify the right-hand side of the equation. So basically, this is what you need to work on first. You need to simplify this, basically removing the brackets. Okay, so this is what we have. So how did I simplify this? How did I remove the bracket? So x times 2x squared, I got 2x cubed. X times ax, I got ax squared. And then x times 2, I got 2x. All right. Okay, how about the minus 2? So minus 2 times this again, I got negative 4x squared. And then negative 2 times ax, I got negative 2ax. And then lastly, negative 2 times 2, of course, it's negative 4. Right? That's how I got that. And bring down b over there. Okay, so this is what we have now. Now, why did I color code this? Because I want to, again, put the same terms together. Okay, so since x cubed is just alone, so I'll just bring down 2x cubed here. That means it doesn't have any pair. I don't have to factorize x cubed. However, look at x squared and x squared here. I have two x squareds or x squared terms, right? That means I need to put them together. So I wrote them like this. So ax squared minus 4x squared. And then, of course, I have x. So I have x here and then another x term here. So put them together. That's why it became 2x minus 2ax, right? And then look at this. I have minus 4 plus b. Since they don't have x squared, or even x cubed, that means that this is my what? This is my constant term, right? So I just rearrange them. So it became b minus 4. Okay, but you can just bring down negative 4 plus b. They're just the same thing. Okay, so this is my constant term. Okay, and then what's next? After you have grouped the similar terms, so you need to factorize them, right? You need to extract the coefficient of each term. So for 2x cubed, I have nothing else to do here because it's just 2x cubed. That means that the coefficient of 2x cubed is 2, right? Now, how about for x squared? So for x squared, I factorized this. So I got a minus 4 and then x squared outside. So again, how did I get this from here? So basically, class, you need to factorize this. What is the common term? The common term is x squared, right? And then divide each term by x squared. So we get a minus 4. Okay, so this is how I got the answer. But for this one, since a minus 4 is your coefficient, you should put this in front of x squared. So that's how I got this one. Okay, and then same with this. So what is how do you factorize this? So your common factor is x, right? X and x, and then you divide each of this by x. So 2x divided by x, you get 2, and then negative 2ax divided by x, you get minus 2a. So that's how I factorize this terms here, and then you just bring down b minus 4, and then that's it. Once you're here, you are ready to compare this to this one. Okay, so let's compare them now. So where's the a and b? A and b. Okay, guys, can you look here? Okay, so you get here a minus 4. However, this is on x squared. Do we have x squared here? In our question, do we have x squared here or x squared term? None, right? Okay, none. Now, if there's none, that means it's equal to 0, right? So you can also solve a by using this or using this one because both of them has a. Now, again, since we don't have x squared here, it's basically equal to 0, right? So you can also do that. You can also compare this. For example, so a minus 4 is equal to 0. Again, it is 0 because we don't have x squared here. We only have x cubed and x. That's why this is equal to 0. So therefore, a is equal to 4, right? So a is equal to 4. So we have a. And also, you can also use the other one. Okay. Okay. You can also use this in finding for a. Since this is 2 minus 2a, and then you have x here, you also have x here, right? So you compare their coefficients. So the coefficient of this is 2 minus 2a, and then the coefficient of this is minus 6. So when you solve this, you will also get a is equal to 4. So yeah, there are two ways in getting the value of a. So okay, so it's up to you which one you want to use. Okay, but I showed this one here. It's because some of you might say, oh, there's no x squared here, so there's nothing I mean to compare to. Again, if there's nothing here to compare to, that means it's equal to 0. That's why a here is equal to 4. But in this case, you also have a here. So you can also compare the coefficient of this with this. That's why I got 2 minus 2a equals negative 6. And then that's how I got a is equal to 4 as well. So this one or this one for the value of a. However, we still have b to solve for, right? So we have b minus 4. So how do we solve for b minus 4? Since this is your constant term, okay, so this is equal to what? To 5, right? Since that is your constant, because it doesn't have any variable x, right? So it's basically b minus 4 equals 5. So where did I get 5? From here. So I'm just comparing it there. Okay, so b minus 4 equals 5. So therefore, b is equal to 9. And that's it. So that's your answer for number 3. So a is 4, b is 9. Again, there are two ways in answering a for this question. If the term is not here, that means it's equal to 0. Okay. So again, class, we are just comparing coefficients. Okay, the coefficients of each term. Again, x cubed is compared to this, right? X squared is compared to what? Where is it? It's none. That's why it's 0, right? And then x here is compared to this. Okay, we are comparing coefficients. That's why I got this, because this is their coefficients. And then this is your constant, so that's also equal to b minus 4. All right, now let's have our last example for today. All right, I jump to number 9, okay? Number 9. Because here, we are looking for um, missing values for a and b and c. So class, we are given on number 9, 3x squared minus 5x plus 4 is similar to a times x minus 2 squared plus b times x minus 2 plus c. So class, we need to evaluate this side, the right-hand side. Okay. So what we need to do first is to expand this, right? So when you expand this, you will get this one. So x squared minus 4x plus 4, right? And then when you expand this, it becomes bx minus 2b, and then you just bring down c. So next is we need to remove these brackets here. And then so that means we need to distribute a inside the brackets. So that's how we got this one. So ax squared minus 4ax, by the way, this is 4ax. We always put the x terms at the last part, okay? It's not 4xa, it's 4ax. We always put the x behind everything, right? And then a times 4 is 4a. And then you just bring this down, bring down this one. Okay, so basically we're here now. And then what's the next step after you have done removing the brackets? So you combine all the like terms. Do we have another x squared? We don't, right? So we bring down ax squared. How about x? yes, we have x here. So we have minus 4ax and then bx. So that's why I put them together here, class. Okay, so put them together like this. And then how about, yeah, that's it. That's for x, right? And then the remaining, this, and this, they don't have any variable x, right? So that means that this 3 here is equal to your constant. So I'll just bring down this 3 here. So they became a 4a minus 2b plus c. All right. Do you guys have any question on that one? So that's your constant value because they don't have x or even x squared. This is equal to this one. This is your constant. Okay, let me color code that so it's okay, easy to follow. All right. So what's after this? So we need to factorize the common term for this one. So we need to factorize this. Okay, so basically when you factorize this, you'll get 4a minus b times x outside. So again, common term is x, and then divide each of this by x. So for example, 4ax divided by x, you get 4a, bx divided by x, you get minus b. Take note, it is minus b, it's because plus divided by negative is negative. Okay, be careful, class, on this one. And then just bring down this expression here, 4a minus 2b plus c, and then that's it. Okay, so we have simplified and factored our right hand side. Now for the next step, you need to compare each coefficient of each term. For example, we have x squared here, right? So we need to compare it from here. So x squared is equal to this, right? So therefore, a is equal to 3. Okay, so a is equal to 3. That's how I got that. Okay, because that's the coefficient of the x squared. So it's similar, so it's equal, right? So that's it. So that's a equals to 3. I forgot to box that. Okay, and then how about b? Okay, so let's look at the other one. Okay, so we have x here, and we also have x here. So we can compare. So your x here is, sorry, the coefficient of your x here is negative 4a minus b, this one. And then that is equal to what? What is the coefficient of x here? It's minus 5. So minus 5 and then this one. So we compare it to that. Okay, that's how I got negative 4a minus b equals negative 5. Okay, so again, I have compared the coefficient of x. So basically, solving for b, since we know the value of a already, it's 3, so it became 3 here. So solving for b, b is equal to 7 on this one. And then lastly, for the value of c, it's basically this one is equal to your constant term, right? What is your constant term on this one? Your constant term is 4. So that's why this is equal to 4. Okay, the whole expression, okay, is equal to 4. And then yeah, so 4 times a, so a is 3 minus 2 times b, and b is 7, and then plus c. This is what we're looking for. So solving this, c is equal to 6. So that's it. So that's your answer for number 9. Okay, so the steps are clear, class. So you need to evaluate the other side, which has a, b, and c. Okay, evaluate and then simplify until here, until you factorize the coefficient of each. And then once you have reached here, you compare the coefficients of each terms. For example, again, x squared is compared to x squared. So when you compare their coefficients, you get, let's say, a is equal to 3. When you compare the coefficients of x and x, you get negative 4a minus b, and then equals negative 5. And then again, this is your constant term. Since it doesn't have any x or even x squared, this is constant. And then this is equal to the constant term in your expression over here. That's how I got this one. Okay.